In a couple of previous videos, we introduced trig substitutions as a technique of integration learned in calculus. In particular, we saw a couple of helpful hints. One is that if you see the square root of a squared minus x squared, we can try the trig substitution of x equals a sine theta. And if we see 1 over a squared plus x squared, we can use x equals a tan theta. Now here's an example where we will be able to use a trig substitution, in particular a trig substitution of the form x equals a tan theta, but we need to do a little manipulation in order to make this integral here look like it'll fit this rule. In particular, right now you can see that we have 9 in front of the x squared, and we don't want to have any coefficient in front of x. We want to have just plain old x squared. So what we need to do is rewrite this integral so that it looks like 1 over a squared plus x squared. What we can do is multiply 4 by 9 divided by 9. So this hasn't changed the value of the integral at all. All it's done is make the integral look a little bit different. And now that we have this 9 here and here, we can go ahead and factor those two 9s out. So that leaves 1 divided by 9 times the quantity 4/9 plus x squared. And at this point, we can bring the 9 all the way out in front, so that now our integral looks exactly like what it needs to look like. We have exactly 1 over a squared plus x squared. Now that we have our integral in this form, we can go ahead and apply the trig substitution of x equals a tan theta. In our case, we can see that a squared is equal to 4/9. So that means that a is equal to 2/3. So we're going to use the trig substitution of x equals 2/3 tan theta. And that means that dx is 2 over 3 cosine squared of theta d theta. So let's go ahead and do this substitution. We have 1 over 4/9 plus, then we can see we have x squared. X equals a tan theta, so that means that x squared is a squared, or 4/9 tan squared of theta. So we have 4/9 tan squared of theta, and then dx is equal to 2 over 3 cosine squared of theta d theta. At this point, we can see we have a 4/9 here and a 4/9 here. So we are going to factor that 4/9 out. So we'll pull the 4/9 in front. So we have 4/9 times 1 plus tan squared of theta. Now that the 4/9 is in front, we might as well pull it all the way in front and make this into 1/9 times 9 over 4. And then let's leave the rest the same. And we can see that the 9s cancel. Now let's also pull the 2/3 out in front. Then this leaves us with 1 over 6. Then our integral is 1 plus tan squared of theta times 1 over cosine squared of theta d theta. Now what we can do is rewrite tan as sine over cosine. And since we had tan squared, that's sine squared over cosine squared. Now we multiply our two fractions by each other. 1 times cosine squared is cosine squared. Then we have sine squared of theta over cosine squared of theta times cosine squared of theta d theta. And our cosine squareds cancel. So that just leaves cosine squared plus sine squared, but cosine squared plus sine squared is 1. So we can replace the whole denominator with 1. So we have 1/6, 1 over 1 d theta, or in other words, just integral of 1 d theta. So this leaves a super simple integration. The integral of 1 d theta is theta, and then we throw in our constant. Now let's go ahead and replace theta with whatever it is in terms of x. So let's remember what our substitution was. We used x equals 2/3 tan theta. So then that means that 3x over 2 is tan theta, or theta is equal to arctan 3x over 2. So that means that our final answer is 1/6 arctan 3x over 2 plus our constant. Now we can check to make sure that the derivative of 1/6 arctan 3x over 2 plus our constant is equal to the thing we were originally integrating, which is 1 over 4 plus 9x squared. Okay, so let's go ahead and calculate the left-hand side. Let's do this derivative. We've got 1/6, 1 over 1 plus 9x squared over 4. Now we need to take the derivative of 3x over 2, which leaves 3/2. And that's because we have to use the chain rule. So let's bring these constants all together. Let's bring the 3/2 in front. So we have 3 over 2 times 6. So we have 1/4 times 1 plus 9x squared over 4. Now multiply these two fractions by each other. So we're going to multiply the 4 through. And that'll give us 1 over 4 plus 9x squared. So that checks out. That is exactly what we started with in the beginning. And so our antiderivative, we can be fairly confident, is 1/6 arctan 3x over 2 plus our constant.